Hi, everyone. Welcome. Welcome to our webinar about machine learning modeling. I would say let's give it maybe 2 more minutes. Let more people join the webinar. And oh, you can't hear anything? Wait. Hello? So you can't hear me? We can
Actually,
hear.
it's fine. It's fine,
Yeah.
I think.
Okay. Can you leave a quick comment whether you can hear me or not? I see both in the chat. Can't hear anything and can hear you. We can hear. Okay, great. Thank you, Foodie Engineer. All right. Okay, perfect. Again, let's give it 1 more minute. I see more people are joining right now. Great. Happy to hear this. That you can hear me. Video too? Hi. Awesome. Great. All right. Nice. More people are coming, joining this webinar. First time that we actually use YouTube for live stream, for live broadcast, and I think it's actually pretty cool. Lots of expectations. Wow. Now we feel the pressure.
Definitely.
Pressure is on us, but
Yes.
that's good. That's good. Now, you know Achinkya, yes, he's
Yes.
pretty known person.
So we have our team joining in.
Nidhi, there's some background noise. Can you mute your mic for a second? Oh yeah, that's better. All right. I would say, yeah, we have a good number of people now. What about the course that we registered on Google Form? Yeah, the courses, we're working on it. I will say a few words to our upcoming course as well. Okay. He's famous in India, all over the world. Achinkya, oh my God, I didn't know. You're a famous person.
Yeah, apparently. I write a lot, right?
Yeah, that's great. All right, cool. Yeah, we get started. All right, again, hi everyone. Very excited to have you in this webinar. Like I said before, it's the first time we're using YouTube to do a broadcast like this, but it's great to have, so many people joining us for this webinar. I will give a very brief overview about data-driven science, what we are working on, and then I will hand it over to Achinkya, who is actually going to walk through this webinar and talk about machine learning modeling. If you have any questions, please use the chat. That's most easiest for us to monitor your questions. And Achinkya can pick up some of the questions along the way and can answer those. Maybe we won't be able to answer all your questions, but we will try our best. All right. So what is data-driven science? Very quick, data-driven science, or DDS, is an artificial intelligence training company. We started end of last year, so fairly recently, and our focus is on creating content around topics in AI and data science. We are currently working on our first comprehensive machine learning course, which will be the first course of hopefully many, which will be published on Udemy fairly soon. We are creating content for this right now. And this is actually also why we are hosting this webinar and other webinars, to get early feedback on the content we are creating. So you will see parts of that content that we are showing today also in that upcoming course. But this course will be comprehensive, like I mentioned, will be a flagship course about machine learning. And we will create more online courses, but also other free content, and distribute those on our various social media channels. So also please subscribe to our YouTube channel. We don't have that many subscribers yet. Again, we just got started and would love to see that number obviously grow. A little bit about our approach. So because there's already a lot of online courses and content about data science and AI on the internet, so that's a question we often hear, like, what are you doing differently? There's already so much out there. And our approach is really about the thought process and practical application. So what we want to achieve with our content that we produce in our online courses that will come is to give you a perspective on how to approach business problems, how to solve those problems through machine learning, through data science, and help you to have an understanding about the thought process, and not so much just the algorithms itself, or just teaching the syntax, because this is not what we think is the right approach. Because in the real world, you will face many different problems, and we want to give you the tools and the frameworks to solve those. About the team, we have four people working on this right now. So Achinkya, as many of you already know. Then there is Nidhi, myself, and Prakash. So we are working together to create that content. Hopefully we will see you also in future webinars from us. And without further ado, I want to hand it over to Achinkya, who's gonna start the webinar and talk more about machine learning modeling. All right, I'll see you later.
Good. Thanks, everyone. Let me just share my screen, and we'll get started then. Okay, perfect. And let's just start then. So I hope everyone can hear me. I'm monitoring this thing from a different YouTube channel so that I can actually see any questions or something. So let's just get started. So you see, whenever we read any news, it's AI, artificial intelligence. It's actually the front of almost all the news. And it's no wonder the possibilities of AI are endless, because the possibilities of intelligence are endless. You see, we are humans, and we are no different from what AI could be able to do, because it's actually has the same capabilities. And that's why there is so much interest in this. So machine learning modeling, which is going to be just let's say one stage in machine learning. So what we are going to have is, we are having this webinar on just that. Okay, so here, if you see, the session is webinar is about machine learning modeling. You see here, it's ML modeling. It is not model. Okay, there is a big difference between these two things. So it's like, I hope you're not thinking model as the Instagram model here, because that's not what I was thinking about. Here I mean model as one ML model. Okay, so let's say it could be, let's say, linear model, or it could be non-linear model, or it could be anything. When I say machine learning modeling, I don't mean that. What I mean is the thought process, the actual experimentation process of going through all the data and finding out what do we want to do with this, and how do we go about doing that. That's machine learning modeling. Okay, so in that, you see, it's pretty complex. Just a second. Here in the ML modeling, we have three stages. One stage is this business proposition. So many a times what happens is, like, if you're joining as a fresher, you are not really expected to have more like a business knowledge or domain knowledge. You are expected to have the practical knowledge, the ability to develop. Okay. But just because you are not expected to have, let's say, business knowledge, but it doesn't mean that you shouldn't have any business knowledge. You see, when we start thinking like a data scientist, we start thinking like an entrepreneur, then it means that I can actually add value to the business which I'm working at. You see, if I can find out new problems which no one thought of, then that's a huge value addition. You see, what happens is, like, in many a times, let's say I have a problem statement, I'm trying to solve that problem. My thought process could become very tunnel, it could become very narrow. I would only see the problem which I have thought of. We don't want that to happen. We should have a general thought process, and for that purpose, everybody should know, what's the business, what is the capabilities of AI, and how can we do that ourselves. Okay, so that's the first stage. When we go from this business value to the next stage, that's when actually we are starting the solution. Okay, so solution development actually starts here. This is proof of concept. So if you are working in a company or an internship, then you should be able to actually see what's the meaning of proof of concept. Proof of concept is, like this says, it's a proof that the project which we are doing is going to be profitable. When we have the proof, it means, okay, the business might approve or might not approve it. Once we have a good, let's say, accuracy, once we have either save a lot of money or make a lot of money, then we can actually say that, okay, this makes sense, maybe we should go into the actual this thing, whatever our production thing we are talking about. Maybe we should create a website around it or business application around it. We can do whatever we want to do from here. So it's the proof of.
Achinkya, I think we can't hear you right now. Can you double check your mic, please? Yep. We also get some comments. So just suddenly dropped. Yeah, we have some audio issues. Working on it. Right back. Okay. Achinkya disconnected. Just give us a minute. We will be right back with the content. Just to look at some of the questions. Yes, there will be a recording of the webinar. We're gonna post it on the DDS YouTube channel, so you can go back and rewatch it. No problem.
Okay, now I'm hoping that we should be, you should all should be able to hear me. I'm just
Yes.
checking the live event so that, there's going to be some delay.
Yeah. No, we hear you, Achinkya. You're back.
Okay, can people, put on the chat whether you can guys hear me or not now? Can you hear me? I don't know if no one has actually said whether they can hear me now or not, but I'm going. Okay, perfect, awesome. So let's just start now. What I was saying was, you see, we have 7 stages of framework, and in which we start with, let's say, problem definition, wherein a business decides, oh, these are the things which are possible here. Then we go, and then we say, okay, maybe I want to go a bit further. Maybe I want to, let's say, create a proof of concept to actually make my case that it is worth investing money in this. After we go from proof of concept, then is the final stage wherein I actually build a solution for consumer usage. So building a solution for actual consumer usage is this production phase. So these are the kind of like 7 stages of machine learning problem, wherein any problem in field of AI, any problem, whether it is, let's say, machine learning, deep learning, recommendation, any problem for any company, they will all have these 7 stages. Okay. In that, we're going to start from this one, then from one we'll go to two, then two is which is nothing but POC. In this POC, what we have is we have grouping like this. So business part is one. When this is done, we are actually kind of like over this. Just a second. When this is done, we are actually completely done with the business proposition part. Now starts the development. So it's like this is the development. So solution development starts from here, and once the solution has been developed and approved, then production is like starts from here. Is like actually final kind of like product which consumers will start using. Okay, so you see, in machine learning, it's like all companies will follow this process, and when we follow this process ourselves to learn what to do, then we are actually ready for, let's say, industry job. Okay, so what a machine learning modeling looks like, a machine learning modeling kind of look like this. So if you have gone to maybe a pub or a party or something or some music festival, you would have seen this is how is the console, audio console of the person who is managing the audio. Okay. We see here we have lots of knobs controlling different things. This is maybe a volume thing. This is maybe a pitch thing. This is maybe a different thing. So there are lots of permutations and combinations here to be handled. Okay, machine learning modeling is kind of like a similar analogy. Okay, what we have is like we have lots of things which we have to choose. Okay, we have to choose, from a lot of options which we have with us, and we have to choose one thing from them. Okay, what do I mean by one thing here is, let's say I take algorithm. There are upwards of 150 algorithms. Okay, based on the problem which I'm trying to solve, it's like I will have to choose the best appropriate algorithm for it. Okay, what, let me repeat again. Based on the problem I'm trying to solve and the data which I have for that problem, we will have to choose the best algorithm for that situation. Okay, so this, in algorithm implementation, I have more than 150, 200 maybe algorithms, and I have to choose one out of them. Then for that algorithm, out of 250 or 150 algorithms, then we have to find out the best hyperparameters for them. Okay, now after we find best parameters for that algorithm, so here we have Akash saying, do we actually have to find the best algorithm? Actually, this is best algo under circumstances, under, let's say, constraints. So I could have constraints of maybe I have a certain money. I don't want to spend any more than that. I mean, is Jan, is my voice still audible? Can you let me know? Hmm. Huh, voice is there. Okay. So we have this thing. We have hyperparameters. So, sorry, the point here was best algorithm. So when I say best algo, it's best algorithm under constraint. It could be cost, it could be money, it could be anything else. Okay. Out of that cost, money, or maybe developer cost, whatever it may be, then I choose the suitable amongst whatever option I have. So when I mean best, it's like best under my constraints. Okay. So I have to do the algorithm implementation. I have to find out the
suitable optimal combination of hyperparameters which I can find out under again my constraints. So I have to best under constraint hyperparameters under my constraint. Then I have to find out features for my data. So you see, if let's say I'm creating a AI doctor, let's say I'm creating a AI doctor, and in my team there is no doctor at all my team is made up of engineers, people who don't even know how to separate maybe cough from cold, maybe. Okay, so it's like if we don't have any domain knowledge, then we will never be able to make a product which can actually help the domain knowledge guys. So for example, if I'm creating a doctor, I actually need to have such an amazing let's say accuracy that that cannot happen unless I have the knowledge of doctor, whatever field it is in. So that knowledge is actually called as a feature. That knowledge is actually called as a feature in machine learning terms. Okay, we have features of the data which we have to choose. Then, while trying to do this 1 2 3 4, we also have to do debugging and understanding of the errors. So it's like it's always happens whenever we are trying to solve a problem, we face a lot of problems while trying to solve the problems. Okay, so the problems which we face while solving the problems, even they might have some problems. So it's like a recursion of problems. We need to able to be in a position that we can debug those problems and fix them. Once we do that, that's when we will be actually able to build a solution. So we have to kind of like debugging, we have to find out what's the problem, we have to fix that problem, then we have to fix the errors which I might be facing. We also have to fix the errors of the model. My machine learning model, let's say if it makes certain mistakes, now we have to find out why it was a mistake. Okay, and then we have to find out how to fix it. So let's say I have errors and my error is maybe 5%. Okay, in the 5% of my error, if it is acceptable, then we will just go ahead with it. But if that is not an acceptable thing, we might need to reduce the error frequency from maybe 5% to maybe 1% or something. So how do we fix this? Do we choose a different model or do we need extra data? That's a lot of thought process which we have to do to fix that problem. Or there is this thing of which is bias of the model or the data or the data scientist. So there are problems in the there could be problems of the cognition as well, which is like data scientist biases. There could be problems in the data as well, which are indirectly creeping in because of all sorts of things. So everything is biased. We have to try to be as less biased as we can so that it does not impact in a negative manner to people who are using it, right? So going back to this slide, so maybe this is a knob of algorithm. Maybe these are the knobs of hyperparameter. Maybe these are the knobs of maybe what else? Maybe error matrix. Maybe these are the knobs of maybe some feature engineering. So you see, when we talk about data science and when we talk about trying to solve the problem, this is what we mean. We are trying to adjust out of all of these things for a specific problem statement. We are trying to adjust it so that we can actually get the answer. So this choice, this thought process is intentional. It's not a blind thing. Most of the times while working with students who are just learning data science, they go to tutorials or courses, they just learn, okay, these are the things which need to be done. But if you are just doing that blindly without knowing why a certain choice is being made, then that's a not a intentional choice. It's a blind choice. It might work, it might not work. A good data scientist is someone who knows, understands the choice made, not just someone who is blindly making it. So a pillar of a good data scientist is combination of a combination of three things. One is knowledge. Okay. Knowledge is a place where not many people lack, actually. If we go into hiring, knowledge, many people have a lot of knowledge. It's just that they still cannot go beyond their knowledge. They can't get hired because they maybe are lacking two things. One is, taking that knowledge and solving solution, the problems a company might be facing. So right now, best place for this is Kaggle. I always tell people, those who are interested in trying to get hired, I always tell them, what's your Kaggle rank? But they don't want to do that. You see, nowadays, we need knowledge and we also need proof of the knowledge. And how can you prove that you have knowledge and how can you prove that you can solve problems? By showing the problems you have already solved. So that's what, pillars of a good attendant is: first is knowledge, second is, being able to do it and having a portfolio of your past work and knowing what you're doing. You see, AI is all about automation, okay? But that automation has to have a very good accuracy, or it has to have let's say, intuition behind it. I can't just blindly apply algorithms and blindly select algorithm which has highest accuracy and blindly, say that, okay, this is the best thing ever. No, we have to find out a solution which is kind of like works, and we know why it works, we know why it doesn't work, we know where it works, we know where it doesn't work. All of these things are part of knowing what you're doing. We don't want to be kind of like doing a blind experimentation. So I don't know if you have seen this movie Indiana Jones, but this scene is pretty iconic when he's going to, take the idol of the gold. At that point, he's trying to adjust. He's trying to adjust the weight. He's trying to replace of that golden idol. And when that fails, then the entire temple goes down. Okay. This is exactly what happens here. Here we are also trying to adjust, but instead of just, juggling one thing, we are trying to juggle a lots of parameters and we are choosing one thing out of that. When that thing works, only then we have our optimal model, we have a correct model. Okay, so we have this thing that, once we do that, then we are in a good position to be get hired. Okay, now it's like we have this ML modeling stage where I'm going to, show you the code, but I'm also going to show you how to approach your study. Okay, this how this content has been designed is, it's code first. Okay, it's code first, wherein you have to start from the code. And my recommendation is always kind of like that code has to be from the documentation, because there are so many tutorials online that I am not even sure that if they have a unique insight, if that tutorial is correct, if it is relevant. Many a times, the best place is like the official documentation, and that should be your kind of like go-to place. Okay, now after this is kind of like you take the code from the documentation. Okay, the code which is from documentation, and now you don't just copy paste it. Okay, this is another common mistake. People just do copy paste without understanding, and that copy paste without understanding is the worst thing you can do. Because, if you just copy paste then it is not going to develop your understanding, right? So, when I say experiment with code, what it means is like we have to kind of like try out different stuff. We have to question, what if I change this parameter? I wonder what will be the impact of it. I wonder, how will be the consequence if I choose some other data. So this experimentation is very important. When we do a lots and lots of experimentation, only then we develop understanding. Only then we develop intuition. Okay, so this intuition is not developed without this experimentation. Now if I spend a time a lot doing a lot of experimentation, then I have to I will develop that intuition. Now if I'm spending time teaching, my intuition cannot be transferred, because for the intuition to be transferred, you have to spend time doing. So experimentation is the most essential part. When we kind of like do this experimentation, that's when we actually gain a deeper understanding. So then we go to the theory. So it's like we kind of like do the coding, then we do the experimentation, we try out different things, and then we go back to the theory and try to relate that theory with whatever we have done, whatever we have experimented, and blah blah blah. So if I go to the this slide, this thing is what we have here. So what we have is any problem statement is going to be a new territory. Every new problem is going to have a different solution. There is going to be a different permutation and combination of stuff which will work on that specific problem. Let me change the color of my pen. So every new okay, even that is not working. Maybe let me make it white. So every new problem will have its own solution. So first, in that scenario where every problem is going to have a different solution, we need to be able to learn a framework which is general across any kinds of problems. So that's what we are going to do. So today I'm spending kind of like just a basic thing, which was simple machine learning modeling, but I'm trying to showcase a different approach which I kind of like recommend, which is experimentation and understanding based approach. Okay, so let's go to this slide, and we will start with the actual coding part. Okay, so I'm going to have these four things. First is the data. Okay, I'm going to have data. Then second is the model. Oh, right now the color is white, so I can't see white on white. Let me change color. Okay, first we have data. So wherever data comes from, whether it is data collection or it is ready-made data set. Okay, then we have model. So my data and my model, they have to correspond to each other. I can't just say, okay, I can't say my favorite model is, let's say, linear regression. I can't just say that, my favorite model is linear regression. It's like, again, model which is machine learning model, okay, not the model you are thinking of. So I can't just simply blindly apply a model which I like to every problem. It's going to be found out for each situation. Then once I'm trying to find out, I need to check how's that model. So this is the training of that model, wherein my model learns. In the early right now, whenever we use word called as training is nothing but learning. So when we are training, we are actually allowing the model to learn. So it's like when we use word learning, or when we say machine learning, then it's the machine, it's the model which is learning. Okay, then that's the kind of like this part. Model is what it learns, and what it does is like we'll kind of like take a look at it. And then once my learning is done, after that we kind of like do prediction or finally perform the job. Whatever job I'm training my model for, that's what my this thing is going to be. My iPad is not being syncing perfectly, so ugly handwriting. Anyways, so that was a lot of this thing. Let's just focus now on the code. Okay, so very basic code, but let's try to understand it deeply. Okay, and when I said documentation is the key, this is what I mean. So everybody should be focusing on scikit-learn API reference. So this should be your go-to place for everything. Okay, and in this scikit-learn API reference, this is everything in machine learning using scikit-learn. Okay, there are a lot of function calls. If you are going through every one of them, I think you'll find at least 4, 5, or maybe 7, 800 different function calls. We are not gonna be able to know all of them. So what do we have is like we have a subset of tools, or tools which is most frequently used. So in this case, I have around maybe 50 something. So there are more than 50 functionalities. Maybe highest thing would be 50, or maybe at most 100. As long as I know and understand and can use these things, I can build generally any kind of like a solution for any kind of a problem. So let me just scroll down right now. This scikit-learn base is all about, basic utilities which we have. One of the most funnest thing in this is this thing, this function called as get config. Let me highlight this. So we right now have 51 highlights. So this get config gives us the configuration. This configuration is the setting of how the machine learning model is going to be. Okay, I'm just checking the chat. It's like based on the, so we have people who are new. Maybe can anybody ask question on who is a bit more experienced? Based on that, maybe I can adjust how am I teaching. So we have around 6-7 people who are completely new. What about rest? Can you ask? Okay, let me just post that comment myself. So can, who has a bit of experience? Maybe I'll see a show of hands. Okay, so we have, okay, perfect. So we have a different spectrum. So let's just continue with what we have been doing. Okay, so this is scikit-learn is a library which is nothing but a library built for doing machine learning. Okay, so let me just stop this. So scikit-learn is one of the most popular libraries because it's quite easy. So let's just focus on that library. And in that library, we can kind of like scroll down. And I'm just showcasing how do we use documentation. So what is a machine learning modeling and blah, blah, blah. Right now, this is what we have. In the code, we are going to do these 4 things. We are going to get the data. We are going to create a model. We are going to create a training of that model. We are going to do train our model, and we are going to do prediction. Okay. So going back to this, our documentation, this is the scikit-learn documentation, and there are different kinds of codes what we have here. Okay, before we do that, let me just talk about a few words to people who are new. Okay, we have this thing called as regression. Machine learning is all about prediction. Okay, machine learning is all about prediction. Now what are we predicting? That decides what are we doing. So if I'm predicting number, then it is a regression. If I'm predicting a class, then it is a classification. If I'm predicting a possible class, I don't know for sure that whether it's a class or not, but it looks similar. It is possibly they are one and the same thing. So we have, if I'm looking for a possible class, if I'm looking for then it is a clustering. If I know this is going to be class, maybe uh, uh, a kind of like a flower or something. Maybe if I'm doing different fruit classification, apple versus orange. So marking something as apple, classification. Marking something as orange, again classification. Predicting something as 3, that's value, that's regression. If I'm saying maybe I could be part of a group which is not normal. So it's like, whenever we go to doctor, we always have 2 readings, normal and not normal. So not normal also has 2 things. It could be below normal, it could be above normal. Then we have, those things have clustering. Okay, as long as it doesn't fall between normal patterns, it's kind of like a different group. That's nothing but clustering. Okay, so when my model, which is this model, so my model here is going to be, okay, let's change colors now. So in my model, I could either do regression, or I could either do classification, or I could do clustering. So I could either do regression, classification, or clustering. Anything is fine. Okay. Based on the problem statement, I just have to choose appropriately. So going back to our documentation, you see, if I'm doing classification, what do I do? I'll simply find out classification, and let me just find out where are the classification algorithm. So I'm simply searching, and it's like, okay, as you see here, there are different things related to classification. Scrolling down, we have something with naive bias. For we have something for neighbors. We have something for neural networks. We have stuff like this. So once I get used to using using the documentation perfectly, getting help from it, and trying to do experimentation from it, that's when I have crossed a threshold of a beginner to, let's say, an intermediate person. Okay, so this is what we have here. Let's go ahead and let's check code. The code which we are going to see is here. So like I said, these are the three stages. Okay, so first stage is data, and here what I'm going to do is I'm taking a extremely basic thing. I'm taking simple 4 points, 0, 1, 2, 3, 4. And for that corresponding each point, I have 0 to 4, 6, and 8. X is 1 to 4, 0 to 4, and Y is 0 to 8. Can you tell me, what is the relationship here? I'm sure this is obvious. Just a second. I'm sure this relationship is obvious. It's like when we say if it had been 1-to-1 mapping, as is, sorry, 0 for 0, the output is 0. For 1, the output is 1. For 2, output is 2. For 3, it is 3. 4, it is 4. It means whatever you take, you give it as is. Here, what happens is whatever you take, you multiply by 2. This is our X and this is our Y. If I do plot of it, what is happening here is we have plot like this. For a point 0, 0, the value is 0. For point 1, the value is 2. For point 2, the value is 4. For point 3, value is 6. And for point 4, the value is 8. Right? This is really easy to predict. Now, I want my machine to learn the same thing. Okay. So I'm kind of like executing this. So let's just execute this. This is my data. And you see, let me just plot this graph here, and this is the graph. Okay, so we have this graph in which this is the way graph looks. Now going back to our slides here, let me just instead of creating slideshow, let's just open this in Zoom. Okay, so you see, we have data collection. This was one of the phases. After that, we have data visualization, which is stage number 4. Okay, stage number 4 is data visualization. This is what we are doing. So when I plot this, what do I understand is like, oh, data looks like linear data. If I would have plotted and I would have seen a weird data, then I would have known that my data is very complex for my model to understand. So it's exactly like this. The complexity of the data we have to find out by doing data visualization. After we find out how complex is my data, I actually go a bit ahead, and then I find out what is the suitable model complexity for my data. So if you think these are lot of words which are not making sense to you, I don't want to say don't worry. Okay, I don't want to say don't worry. It's like this thing is like, if you're learning for the first time, then many of things are complex. So for you to understand something more, don't just ignore what you have not understood. simply Google search on it. Anyways, this is present on YouTube. You can find out the word which you did not understand, search it on Google. Google is the knowledge genie now. Anything we don't understand, we can search, and the information and answers and everything is going to be available there. Okay, so we should be really leveraging what we have in Google. Okay, so then next step is this. So I'm doing something. Okay, I'm doing something here. Let's just call it this phase wherein I am preparing the data, which is like stage number 3 here. I am preparing the data so that I can actually start doing machine learning. So data preparation prepares the data for ML modeling, which is like from 3 is preparing data for 5. Okay, let's go here. And now this is the code. So again, don't think of this as a coding which you have to remember. You simply have to have a vague idea, and then you do the code yourself. Okay, so let me just open Anaconda. Anaconda is the Python distribution which we will use to do this coding. Okay, so I am currently using this Google Colab site. I will share this with everyone. For now, let's just wait for the Colab to get started, and I'll do the coding in front of you. Okay, so you see, in reality, coding is kind of like done live. When we are trying to solve a problem, we have to solve it. We have to do the whole thing ourselves. Okay, so this is Anaconda. If you want to start with machine learning, then you might want to install this. And after you install Anaconda, we are going to launch a Jupyter Lab. Okay, Jupyter Lab is what we'll be using. Let's just wait for this to launch. Okay, it's on. Here I'm creating a notebook. Okay, this is the notebook now. Let's just zoom in a bit. Let me just minimize this, and I'll just give you a bit of tutorial of what this Anaconda is. Okay, this is a place to execute Python code, or or data science code. So when I go to file, when I go to new, I can create a file here, text file, and let me just rename this file. Let me do it as a Python file. So hello world, and let me just make it py. Okay, so when I open this file, this is a Python file, not a Python file. It will become Python file after I write something. Let me say print hello world, print welcome, and then print bye bye. Okay, this is the code which we have written. Very simple, nothing complex. If I select this, okay, and do right click, this opens create a console for editor, and I'm just going to select Python 3. Okay, so what I've done, I've selected whatever I want to execute, clicked, did a right click, and created a console. Okay, now in this console, I simply have to, I can drag and drop this in any way I want. So let me just do it in such a way that it is in a, instead of horizontal, it is in a vertical mode. Okay, so now I can look at the code and the output of the code in a much better manner. I like vertical mode. So let me select the code I want to execute. I've selected hello world. Now for me to execute this, I can't just say right click and run. If I want to run, I can go to menu run and select this thing, or I have to press shift enter, whatever the shortcut is going to have. If I want to run welcome, let me do that. Welcome has been executed on the right hand side. You see welcome. It's like it's just printing what we are trying to print, so it's not that easy. So let's just do a equal to 500, e equal to 769, and print a into b. I'm selecting this, shift enter. So you see the multiplication of these two has been printed. Okay, so going forward, this is Jupyter Lab which we are using, and in the Jupyter Lab we are going to do the code. Okay, so let me just copy paste in the code which we had in the beginning, this code. So copy paste this We don't need this anymore. Okay, so this we have done. Until now, none of this needs to be remembered. Okay, the amazing thing about Jupyter is, it also gives you a lot of help in terms of prompts. Documentation is great. So if I need some help on, so we see we have a NumPy library. In quickly, NumPy is nothing but a library in Python, which is simply allows us to work with arrays, numeric arrays. Then we have matplotlib. It's like, as the name says, this is a library for doing plotting. Okay, so we have stuff like this. Once it is executed, we actually have this output. Now let me tell you another way of getting help. So let's say I want help on linear regression. I can do right click. Okay, and you see, after I do right click, there is this thing called as show contextual help. Let me select this. Okay, and this has opened as a new tab. I don't want a new tab now. I want to again do this like a split thing. Remember, I can simply drag it. I can drag it in a complete thing. I can drag it half. I can drag it as a half of right hand side. If I want, I could also do something. Okay, let me just create a new file, Python 3. Okay, and I could drag this file in the bottom half here. Okay, so I have this, one code here, one code here. I could be doing a lot of things, so I can do lots of permutations and combinations. Okay, so by doing right click, I have selected show contextual help. Let me just put my cursor on this linear regression. Okay, so after I put my cursor on linear regression, automatically on the right hand side I get the documentation. Okay, I don't have to go to documentation of linear regression on scikit-learn. Okay, so if I do linear regression and scikit-learn, I search that, it will of course redirect me to the original documentation. And that original documentation, we will have everything. Okay, this will list what argument does linear regression take. If I scroll down, it will give me what are the stuff related to it. If I go down, there is an example for linear regression. Okay, you see here, if I scroll down, it's the exact same thing. The same example is visible here. I could copy paste this. Now it's of course better if I copy paste it from here, because I can click here, hide prompts and output, and I can actually get a code as is, which I can copy paste. So maybe we can, for regression, we can do this example. Okay, what is this example doing? It is taking this thing like this, blah 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 blah. But our example is easier. We are simply taking y is equal to 2x. Okay, let's just click here, and on the right hand side it is giving me help. So you see, I don't have to remember anything. I just have to know what I want to do. I want to do reshape. Okay, if I click on reshape, this will give me a documentation help automatically. So I can learn the syntax. So it's not that you will never have to remember syntax. More you do this hands-on, you will automatically remember your syntax as a muscle memory. Okay, you don't have to remember it explicitly. You don't have to sit there trying to remember and do rote learning of the syntax. What you have to do is, like, you have to do conceptual understanding and you have to do practical problem solving. When you do both of these things, you are done. You will remember everything you need to remember. Okay, so this was right click and contextual help. And now let's just simply check the slides. So we had this wherein we were talking about stages. Okay, let's just scroll down to this part. We had data, then we have model, and now we have to train the model. Okay, so for training, the function call is pretty simple. Okay, the function call for training is model.fit x comma y. My data is small x, my thing to be predicted is capital small y, and I say model.fit x comma y. Okay. Now, what is X and what is Y? I'll simply select this. And on the right hand side, I will get the documentation help. So this is the amazing part. When I do documentation help, I get, okay. So let me just go here. Let's just call C model.fit. And let's see, what does fit do? Fit takes in X as an input, Y as an input, and it also takes in sample weight. Okay. If I can, whenever there is a equal to sign in Python, it means that it's optional. I don't always have to pass it. Okay. And this is object oriented programming. So self is, you can easily ignore. Self simply simplifies, implies that it is a object oriented programming done in Python. Okay. So we have this function fit. Now, if I go back to this, now the final answer is like I have done the training. Training is done here. Okay, in the one sentence, it said training is done. If I go forward, the final thing to do is doing prediction. Okay, so let's go here. How do we do prediction? It's model.predict. Okay, and how do I give in something to do prediction? Okay, this predict asked me X. It asks me array. Okay, so I'm simply going to say, let's say predict 7. I know this is going to give me error. And why, I will explain it to you after you are a bit more advanced. Okay, so the truth is, for this to work, this has been already told in documentation. If we check, you see this needs to be given in this format, 2 square brackets. Okay, so I'm going to do the same thing. I'm going to do 2 square brackets and then I give 7. So what's the output? What's my model giving me as output? It is giving me 14. When I ask the question, what is the relationship between X and Y? Everybody answered it is 2. Y is equal to 2x. Machine also has learned y is equal to 2x. Now, machine has simply learned a stupid example. Doesn't mean that it's the only thing it can do. Okay, same problem, but instead of having such a simple relationship, we have a much more complex problem, which is like Zillow. If I go here, this is nothing but a competition, which is nothing but a housing price competition. So real estate company, they are trying to predict price of the house. Okay, now when they're trying to predict price of the house, it's a number which they are trying to predict. Simple, it's a number they are trying to predict. Now, what do they have? Let's scroll down here. If we check, they have, instead of having 5 example, they have around, I don't know how many. Let me select in 2016. How many examples do they have? I know, I think it's around 3 million. So, and how many columns it has? This has around 58 columns. So you see, when we did this y is equal to mx plus c thing by using a simple model, it was very simple. Of course, it was very simple because the data we took was simple. Now, when we make the data as a complex data, we get a complex solution, a thing which we wouldn't have been able to do by ourselves. Okay. So this was the model and this was the training. So you have actually very quickly understood a basic thing, which is what is a data, what is a model, what is training, and what is prediction. Data is nothing but data which we are going to use to do some prediction. To those people who are new, one of the best resource which you can actually follow is explain like I am 5. Not river, 5. So explain like I'm 5. This is an amazing thread on certain websites where you can ask any complex question as you can, and that question is answered by domain knowledge experts in that field in as simple language as they can. Okay, so explain like I'm five and data machine learning. Okay, so here there are few blogs, there are few posts here. If you go through them, you will actually understand in a very intuitive manner what is machine learning. And then on top of that, you can build your understanding even further. So I would really recommend doing this. It will be very helpful. Okay, going back to Jupyter Lab now. We have done this thing. Our code was this model.regression. Let me stop the contextual help so that we can see more code. And maybe let me just make the contextual help in the bottom part. Okay. So we have linear regression. Then we have model.fit. They have model.predict. Okay. Let's go into a bit more details now. If I want to do something else, if I want to do even complex things, what can I do? Okay, so we are going into a bit more advanced stuff and advanced stuff of this thing. So we have seen a bit of code, we have seen basics code, and you have to experiment on that code yourself. Okay, now let's just check maths of this. Okay, everybody hates maths, especially in machine learning, because it's very complex. Okay, but when we take a simple problem, the maths becomes simple. So the data is what we are trying to just a second. Data is what we are using to do prediction. Okay, this is the data. Okay, then we have a model. Oops, I need to go to previous slide. Okay, okay, this is the data, and then model is nothing but a kind of like mathematical function. Okay, so when I do the training, okay, training we did it using simple function call in Python. Okay, when we do the training, then we have to do the prediction. Okay, prediction is nothing but value of y, which I am predicting. It is actually simply nothing but a function of x, which I have given as input. So going back to this example, our function was y is equal to 2x plus 0, right? And in y equal to 2x plus 0, when we give x value as 10, what was 10? 10 was something new data. And for that new data, what would be value? That was our question. A simple question. But this solution works for a complex problem as well. If there were around 500 different things with a very complex relationship between them, a human might not be able to even do that calculation and learning of what is the relationship. But this machine learning model which we have created in scikit-learn, it will easily be able to do that. Why? Because complexity and scalability, it's like if we simply do the right thing in terms of code, this will scale. This will run for as much complex as data we can think of giving to it. That's the stuff about computers. We simply give it instructions and it will do whatever we tell it to do. So the model is y is equal to mx plus c. Okay, and when we kind of like are doing prediction, I'm giving y is equal to 10 into, sorry, not 10, 10 into, this was what, 2, right? So instead of writing 2 into 10, I have written 10 into 2. But I hope you understand. M is here 2 and the x is here 10 plus 0. So the value which I predicted, it is 10. Okay. Here, what was the data we gave to the ML model? For 0, it was 0. For 1, it was 2. For 2, it was 4, right? So here value is x is this, and this is y. Okay, and was this predicted or was this already given? The value of y. Value of y was actually already given. So this was the actual given value. And this is why I have the subscript here. So I am doing, why the thing I'm trying to predict. And I have added a subscript here so that I understand. Y is nothing but I am predicting. And predicted is, just, telling me it's a predicted value. And what is error? Let's say I know output of x as 10 is equal to 20. Then what's the error? What was the predicted value? Predicted value was actually 20. And I am told the actual value was also 20. So error is 0. But let's say if I'm told the actual value is 40, then what's the error? Error is minus 20 because actual value was 40 here. So when error is 0, it means my system is perfect. When error is highest, it means my system is not perfect. Maybe I have done something wrong. Or maybe data has a lot of noise. Or maybe even data is wrong. There is a lot of complexity here, which is part of machine learning. And that is why in the beginning, I said the analogy of professional audio professional showing his entire working kit. There are lots of knobs, things which you have to kind of like change, and by selecting the right one is like we find out the best combination of something. Okay, let's just go ahead a bit and let me just talk about in this situation. Okay, so I talked about a thing called as parameter. Okay, I didn't talk about parameter, but I did mention hyperparameter once. Okay, so let me just talk about that, and let's just understand this from the code. So when I say do maths first, then it's a wrong approach if you are a beginner. I always say do code first. It's a perfect approach if you are a beginner actually. So what did we do in code? This was our code. Okay, what was our code? It's like y was this, x was this, and something. But now this is no longer enough. Okay, now I want to actually add some noise here. Okay, so here in scikit-learn, we can either create this function. Okay, I can say x is equal to something, y is equal to, maybe let's add some noise. Okay, I've changed the code. I've made it a bit not so good. Okay, so when I scroll down and when I go to the model training, and when I say model.predict of 7, I get output as 16 point something. Answer is almost 17, not 14 as I would have expected. Why? I don't know. And that's what it learned, right? So what I'm trying to say is, like, when we had thing like this, which was 2 and 4 and 6 and 9, 8. Okay, what I'm going to do is, like, I'm going to add something different here. I'm going to make it 3 instead of 2, 5 instead of 4, 7 instead of 6, and 9 instead of 8. Or to be even better, let's just make it 2 plus 1, 4 plus 1, 5 plus 1, and 8 plus 1. Okay, x is equal to 0, 1, 2, 3, 4. Y is equal to 0 plus 1, 2 plus 1, 4 plus 1, 6 plus 1, and 8 plus 1. Okay, now what has happened is, it is still y is equal to 2x, but now it is 2x plus 1, right? Now if I kind of like go here, do this model, train this model by saying calling model.fit, and I do model.predict, it's gonna give me answer as 15. Okay, going back to this thing, remember This is a linear relationship. Okay. So I know it's going to be y is equal to mx plus c. M here is 2. C here is 1. Okay. So when I train, okay, when I train my model, it actually learns value of M and C. This is what learning is. Okay. Let's say if my model is, y is equal to M1 x1 plus M2 x2 plus M3 x3. If there are three things, then I could say that. Okay. Or if, let's say, my model could also be this thing, y is equal to 2x square plus 3x minus 7, right? Or let's just say y is equal to x raised to 709 minus x raised to 603 divided by x raised to 1 something something. Okay, let's say this is such a complex equation. Okay, now no human will be able to guess what is the relationship between x and y, no matter how much data is given, if the function data is so complex, right? But for this machine learning model, it's not going to be any different. Okay, as long as we have enough data, machine learning will learn if we train on it. Of course, if it I have made the right choice of the algorithm, only then it will learn. Okay, so going back to what we were saying, when I say y is equal to mx plus c, it learns m and c. Okay, it learns M and C, and let's just see where is it saved, right? I'm curious to see that. I'm curious to see where it is saved. So my recommendation for everybody is this. So I was telling you a bit more detailed about this, which is I told you about contextual help. Okay. If you don't have time to do the contextual help or search the documentation, then there is one more thing which is essential, which is shift tab. Okay, shift tab, I have to execute it on a function. So if I go in a linear regression thing and I press shift tab, it will automatically do this autocomplete. If I do shift tab inside, it's the same thing, right? So when I do shift tab, it tells me what input does this function or a class take. So it takes X something. Do I it takes argument which is copy, it takes normalize or something. Let's not go into this, but for now we are just sticking to basic stuff. So there is this thing shift tab. Then there is another help which I'm saying is like split mode, we have talked about, and this also we have talked about. So I won't talk about naming conventions now, but yeah, we have covered important stuff in how to use this tool as a editor. Okay, going back here, going back to the code, and okay, just a second, I've forgotten what I'm trying to do here. I did this complex. Yes, I am curious to find out what has the model learned, and there are two functions which can tell us to do that. Okay, what has model learned? Those functions are, one is vars and other is dir. Okay, this is a Python function. So you can call vars like this. So let me scroll down. I can call vars of model. What this does is like it gives all the variables which are saved in the class instance model. It tells us all the variables which are saved in this class instance model. Okay, if we go to documentation, and if I go back to documentation, let's say API reference, this is the API reference, right? Let's scroll down, and for everything there are these functions. Is it a classifier? Is it a regressor? Is it get config or something? Okay, this is the get config one, and let's just execute that now. So model dot get config. Maybe it's get config like this. Okay, I don't know what is the function exactly. So we have this as a vars gives us the variable names. Okay, there is another function which is dir of model. This lists all the functions which are the or all the variables which can be called on this model. Okay, so if I scroll down, there are these functions. These are nothing but private functions to this. What is estimator type, get param names or something, and residue. We have coefficient, we have copy x, we have this function called as get params. Okay, if I go to linear regression, I think I remember seeing this. Okay, if I scroll down, yeah, what are the methods of linear regression? It is either fit, there is one called as get params, and there is another predict, and there is score. So let me just call that get params. Okay, remember I executed this. Where did I execute it? Execute it here. So there is a get params, and this is intercept something. So I'm calling model dot get params. This gives me list of parameters. Okay, there is something called as intercept. Okay, I am not sure whether this is a function call or if it is a variable. So I'll just try it out. I'll say model dot what is intercept underscore. I'll just try calling it as a function. Okay, it's saying it's not callable. I'll simply call it as here, and it will tell me a number. Okay, and I know it is a variable. Why? Because this vars of model, var is nothing but variables. This vars of model actually gave me that value. So you see, this is what we have as an intercept. This is what we have as a singular. We have rank as one. We have residue as something. We have coefficient as something. Okay, let me print out what is coefficient. So let's just do this model. CO model dot this. So we have coefficient is 2 and the intercept is 1. What was our function? Y is equal to 2x plus 1. You see, model has learned. And if I go to residue, and I would have found it out in this, if I search residue, okay, residue is not here. So maybe you might need to kind of like go inside the documentation. So we can do it here. Oops. We can maybe do the getting help of this thing here, residue. But for now, let's not do this. If I print model dot residue now, what was the residue? PQR residue is not here. Oh, it's underscore residues. Okay, so residue is 1.3 into 10 raised to minus 30. What does it mean? It means the error is so less. Now let's go back and change the data. Okay, let's make it 1.3, 1.99 minus 1.86 plus 10 and minus, let's say, 100. As you can see, I have added a lot of noise here. Okay, I've added a lot of noise. So I don't know what is the relationship between X and Y. Okay, so I need to find that out, right? I don't know what is the relationship between X and Y. I need to find it out, but for now, let's just see if it is linear. Okay, so I've plotted this thing, and when I do a plot, it looks like it is not linear. Anyways, I have very less points. So which algorithm to use when is one of the most common questions, and the answer to those questions is always, we need to find it out. So what algorithm should I use whenever a data is something like this? Whatever data it might be. Okay, the answer is we'll have to find it out. So even in this situation, when I have changed the data, I'll have which algorithm should I use? I'll have to find it out. So trial and error is the answer. I have to try, see what works better, blah, blah, blah. Now what we have done is like we have changed the data, we have made it noisy. So let me call training again, and let me just print intercept, coefficient, and residue. So you see, if I assume the data is linear, then its slope would have been 21, its coefficient would have been 17, and it is very high error. So residue is nothing but error. So when I see error which is very high, it is most likely not the right choice for my example. So I need to try out different things. So this gives me a kind of like understanding of when should I move on to trying different things. Okay, so I should maybe move on to trying different things. So that's the kind of like part. So going here, the complete machine learning modeling is very complex. Okay, here the feature engineering part is actually a separate stage. This is stage 6. That's why I have kind of like tried to keep it separate. But otherwise, at least these 6 things, these 9 things are part of ML. Even data thing is not. So at least these 8 things are part of machine learning modeling. A thing like what's my model? Okay, you see here, I've chosen the names very carefully. The first thing is machine learning model, not modeling. Then this thing is a bit complex. Error function or loss function. Remember, this was the error. This was the error function. What do I mean by that? I simply mean this. Let's plot something. Okay, let's say I'm plotting a curve like this. This is something curve E, and this is a variable called as W. Okay, I want to find out what at what place is E minimum. So of course, when I draw a plot like this, it's this. Okay, so this is what exactly is minimizing error. So this E is nothing but error, and this W is nothing but weights. Okay, so you see, when I can't simply keep on saying y is equal to m1 x1 plus m2 x2 plus m3 x3 plus m5 x raised to 7, something like this. No, I can't keep on saying that. That's why the answer is, let's just take everything which is, uh, a, a, a parameter. Let's call it one word called as weight. Okay, so there is this thing. So m is w1. So whatever function I choose, this it gets called as weight. Okay, and what is error? Error is like nothing but this. I already plotted a graph. We have error, which is nothing but y predicted minus y actual, and we have nothing but weights. So at this place, the value of weights is something. At this place, the value of weights is something else. And you see, weights is a vector here. It could be a single value, or it could be 2 values or 3 values. So this graph could be either 2D or 3D or 4D or 5D or 6D, 7D, or up to infinite Ds. So for every different point in space, we are actually going to have different values of weights. Okay, and when we want to find out the best values of weights for which error is minimum, zero, not minimum. Okay, we want to minimize the error. If that minimized error is zero, that's amazing. I don't know what's the meaning of negative error. Maybe depending on how I define it, maybe. But I want to minimize the value of error as much as I can. That is what the training does. So when we call ml.fit, this is what is happening internally. Okay, I know this is going a bit more complex, but we are trying to connect everything to actual theory now. So we have seen the code now. Okay, we have seen the code. We have not seen this, place where error is equal to y predicted minus y actual. No, that part of the code is not there. Maybe I might need to do that by myself. But in scikit-learn, everything else is there. So that was simple machine learning, which was this. Now, if we go to complex machine learning, then we have to do error function. We have to do training. We have to do prediction. We have to do what is a metric. We have to say the evaluation. We have to say what is the ML modeling, and then we have to also say what is hyperparameter tuning. Okay, so let us start the code from step number 1, data for machine learning modeling. Okay, and everything I'm going to do it in front of you guys so that you know how to do it yourself. Okay, so maybe let me just put this documentation on the right side and this code on the left side. Okay, perfect. So we have this thing. Let me zoom this out a bit and we are ready to go. Let's go to home screen, API reference. So in data, okay, there is these functions which are very important. Let me simply maximize this first and show you. If you search generator, okay, remember what did we do here? We were trying to create data for ourselves by writing the function manually. I mean, I can't do that manually. How many permutations and combinations can I track? Right? It's not possible for to do this. So that's why what I have to do is like I have to use a function which, okay, we will be on for maybe 10 more minutes, 10-15 more minutes. Okay, so what we have to do is like maybe I can use a function which I can call to create data. Okay, so that function is this. Scrolling down, sample generator. Okay, there are around more than 10 functions here, but there are only few importance which I've highlighted. There is thing called as make blobs. This creates data for cluster. There is another thing called as make circle. It's kind of like circle data. Sometimes I might need it, but generally it's not that useful because it's small 2D data, right? Then we have make classification. It is classification data. Okay. Then I have regression. This is regression data. And if I scroll down, there is another function which is important. It is sparse. Why is this sparse important? Because it is sparse. Generally, sometimes we need to learn what if the data is sparse, what should we do then? So these functions are important. So right now I want to learn what is make regression. Okay. So make regression function is like this. So let's just learn how to read documentation. So it is present in scikit-learn datasets make regression. So if I scroll down, there is going to be some examples which are using this function. Okay. So let me see. I think this looks nice. This looks easy. Okay. So if I scroll down, it is nothing but from scikit-learn import data sets, and from data sets it is saying make regression. Okay, fine. Let me copy paste this. But I can choose to write it any way I want, right? So let's scroll down here, and now we are creating our own data. Okay, so let me close this stop this from scikit-learn. And okay, so number of samples means how many data do I need to create, how many data points. So I'm creating 1000 data points. Then number of outliers means I want to create some points which do not fit the pattern. Okay, so I'm saying number of outliers is equal to 50, but that is not being used here. Where is it being used? Oh, it is adding noise explicitly. Okay, so I don't want to do that. Okay, so I'm going to my code, I'm removing this. Number of samples I'm giving as 1000. Number of features I'm giving just one. And let's say if I had given features as 10, it means there would have been 10 columns. Okay, I don't want that. I only want, okay, I'll show you. I told you always experiment yourself, right? So let's just say number of features is equal to 10, and informative is 1, noise is 10, then coefficient is true, and random state is equal to 0. So let me execute this, and let's just print X. Okay, so instead of 10 features, let me just make it 3 features, and number of samples, let's make it 5. Let's just execute this again. I executed by shift enter. As you can see, what is the array? Is this. There is another function called as shape. When I say x dot shape, it will give me what is my matrix. This is a matrix of 5 rows and 3 columns. So 5 is this number of samples and 3 is number of features. So I want to create a data for linear regression which is 2D. That is why I am not gonna say number of features as more. So I'm going to keep it as 1. Okay. But if I had said like a number of features are 3 and number of informative are only 1, what is number of informative? Let's just check here. Number of features which is used to generate the output. Okay. It means if I have 3 features which are these and I have 1 informative feature, it means out of them only 1, okay, only 1 is causing the output, rest are all noise. So stuff like this, when I start to get hang of using functions like these, I truly get a in-depth understanding of uh, the data as well, and I can try different stuff on that data and I can refine my learning. Okay, so this was the kind of like thing I wanted to mention a lot. This was the kind of like part which is important. So if you are going to do hands-on, if you are going to do your own experimentation, now the data which you should be using is nothing but sample generators. Okay, it is essential. When you do that, that's when you will have complete control your data over your data, and you can try different stuff. Like I said, try stuff, call vars function, call dir function, try to see which different functions are available, which different variables are available, try to see meaning of everything. Do something on code, experiment, try out different stuff, then read theory on it, then try to understand it better. If you want, you can also read the scikit-learn code, try to understand it even better. So deep understanding starts from experimentation, and that would be my recommendation if you want to take this session any further. Okay, so going forward into slides, we will, in the next part we'll go into bit deep into this. Right now we don't have enough time to go in deeper into this. Okay, so what I want to conclude with is, like, we have already seen the code. I want to conclude with the importance of experimentation again. You see, when you experiment, that's when and only when is when we develop a deeper understanding. So we need to do experimentation a lot. It will develop our intuition, it will develop our understanding, and that's how we should be developing our knowledge. Okay, so my recommendation is, like, you should be doing experimentation until you know everything like back of your hand. Okay, you should be so familiar. Okay, you should know, okay, k-means doesn't work on this kind of like data. For text data this works better, for this works better. Everything you should have experimented in different permutations and combinations so much that you know everything like back of your hand. Okay, but you can't always know everything. Okay, so one should also learn how to find out what we don't know by doing experimentation. So like my recommendation is like, experiment to find out all the intuition, all the understanding, all the coding, do that. And then whatever you don't know, again experiment to find out what's the answer for that case. Okay, so this is what we should be doing. Experimentation is essential. Data science is the experimentation science. It is not a exact science like physics. In physics there are rules which specify and explain every single thing, whereas in data science it's more like a experimental science, wherein we try out stuff, find out what works, and then we use what just worked. We might not have explanation for what worked still. Okay, so this is what I want to use to conclude the webinar we had today. So it was like a bit code and maths heavy, but I hope this made sense. If you can kind of like do this coding thing by yourself, you will have a lot more value going forward. Okay, so I'll kind of like, that's it from my side for today. Let me just pass on the mic to Jan, and he can kind of like take it further.
Yes, thank you so much, Ajinkya. First of all, yeah, big round of applause, virtual applause to Ajinkya. I think that was a really great session. I saw also a couple of questions in the chat about whether this recording will be or this webinar will be available later. Yes, of course. We will put the recording on the DDS YouTube channel so you can rewatch it, and things maybe didn't get and just want to go back to them. You can do this in the recording. Also, we will have more webinars in the future. We haven't decided yet on when the next will be, but everyone who has signed up for this webinar we will keep people posted about any future events. Also, follow us on our social media channels, subscribe to our YouTube channel, follow us on Twitter, Medium, and so on. We will frequently post updates about what's happening on our site. We'll provide links to content that we create or we find interesting. And in the meantime, we're also working hard on our first online course, comprehensive machine learning course that I mentioned at the beginning. Again, once the course is published, which will be very comprehensive. Ajinkya shared the 7 stages framework. So today we talked about 1-stage ML modeling, but in that course we will then cover and go in detail into each of the stage. But we'll keep everyone posted. All right. So yeah, thanks again for joining this webinar. It was great to have you here. Have a good evening, and we will see you soon. And oh, by the way, I'm going to send out a feedback form, and it would be great if you can give us some feedback about the webinar, what you liked, what you think could be improved. This will help us for future webinars to make them even better. All right. Thanks, everyone. See you soon. Bye.